review anywhere, or either of us are not listening, just let us know. Okay, I did hit the recorder, so we are recording the lesson. So if you guys need to go back, you can. Okay. So you should be, I'm going to go ahead and share my screen to begin with. Ms. Rondeau, this is our first time doing this, so we kind of worked it out who's teaching what part of the lesson, so you're going to get a little bit of both of us today. Today is kind of actually a fun lesson. It's one of our more favorite ones to teach. We're going to be reviewing right triangle trig. So you should be seeing my screen now, okay? And you should now be seeing a PowerPoint of my screen. I'm going to present that PowerPoint. All right, so I'm not seeing the chat anymore, Mrs. Rondeau, so just so you know, I'm only seeing my screen. So, is it 45? I thought I looked it up. So it should look something like, let me show you this page. It should look like this. Use trigonometry with right triangles. Okay. So I'll pop my PowerPoint back up there so you can see the, so you said it was 45, Mrs. Rondeau? Okay, apparently I'm wrong. That's why there's two of us. All right, we're going to give you a minute to write. I know we're not at school, but we're going to give you a minute to write down that essential question. We're going to pretend it's just like in class, because who knows, we might be practicing this for next year. So, how are trigonometric functions used in right triangles? And we're going to probably spend about 3 days or so on this lesson. We're not going to get through all of this today. We're going to basically review all the right triangle trig you used in geometry, but very, very rapidly. You learned it in probably over a couple of weeks in geometry. We're going to do it in just a couple of days. So how are trigonometric functions used in right triangles? Right, there is some animation that goes on with this PowerPoint, so hopefully you've got your screen where you can see the screen full. My PowerPoint kind of full screen would be great. All right, so the first thing is that we have what we call a reference angle in here. I don't know if I can get my pen to work. Oh, my pen is red. All right, we're going to go with red pen right now. So this is what we call the reference angle of the triangle. It is usually labeled. It doesn't necessarily have to be this bottom angle. It could be this top angle, but it's usually labeled with this Greek letter theta, is what we call that letter, is theta. Okay. And trig ratios are what we use in right triangles. The two angles other than right angles are called reference angles. And I'm going to pause a little bit at the end of each slide, just to give you time to write. I know a good chunk of it, but probably not all of it. I know alpha and beta; those are the A and the B. So, and I know pi really well, and phi, and sigma. So I use a lot of it actually, but not all of it. So, oh, we'll have to have you do that. Maybe at the end if everybody's good. All right, keep going here. So this one's animated. I'm going to probably do it more than one time. So if you're not catching the animation, that's okay. I'm going to have you guys write it, and then I'll go back through the animation one more time. So there's 3 different parts to a right triangle in the context that we're going to see it today. So we have our reference angle, and we always start there. We know that the hypotenuse is 100% of the time across from the right angle. And then we know that the opposite leg is 100% of the time across from the reference angle. And finally, we know that the adjacent is 100% of the time next to the reference angle. It's I always do that one last because I know where the opposites are really well. And the last one is that way that's always just the one that's left over. All right, I'm going to try to figure out, oh, there it goes, to go back through the animation. Oh, I figured out how to change the color of the ink. Okay. I'm going to go, oops, I'm flipping back. All right, so I'm going to do that animation one more time. Across from the right, across from the reference, and next to the reference angle, so you can see kind of where it landed. Okay, I'm going to go to the next one. We're going too fast. Put it in the chat and let Miss Rondo know. Okay, so this next part I want to show you in your notebook, okay? So in your notebook, the intent from this is that you write your sine, your cosine, and your tangent above the line, and then you're going to write the other ones below the line. You'll see it when it pops up. Okay, so right now you're writing above the dashed line. Okay, oops, I'm in the wrong spot. So write this next part above the dashed line. It's going to teach us about each of the ratios now. Okay, so on your first triangle, all you need to do is label opposite and hypotenuse, and we kind of abbreviate it OPP or HYP. I even get more abbreviated than that. I'll usually just use an O or an H. Yes, we are. And then, so it's the sine of theta equals the opposite over the hypotenuse, and again, write that above the dashed line. And the first three, these are ones you should have learned in geometry. All right, you probably have no excuses because a lot of you had Ms. Rondeau for geometry. Cosine of theta is adjacent over hypotenuse. So label the one next to the reference angle adjacent and the one across from the right angle of hypotenuse. And then the ratio that we're looking at is adjacent over hypotenuse. All right, our third trig ratio is tangent. And we don't just say tan. Oh, just like we don't just say sin on sine. Okay, it's sine. So we have the opposite and the adjacent. And so we have the trig ratio. The tangent is the opposite over the adjacent. Okay, so now you're going to switch and write below the line. So you're going to go back to underneath the sine. So you want to be underneath the sine on your dashed line. We have the same triangle. It's still the opposite over the hypotenuse. And all we're going to really do is flip the reciprocal of the ratio, because the ratio can be done either way. So what we call the cosecant, you can see the word typed out right here. It's called cosecant. It's the reciprocal of the sine, and we write that as hypotenuse over opposite. So these three are new this year. I don't believe you do these in geometry, do you, Mrs. Rondeau? Yes, we're learning it. Yes. We'll talk about that even later today, because I've got the story that goes with it. All right, the next one. We've got secant. So this one should be underneath your sine, or your cosine. It's called secant, so the word is written right there. It's the reciprocal of cosine, okay? And it's the hypotenuse over the adjacent. So make sure you're at least getting the ratio written down. We obviously abbreviate all of the trig ratios. They're all 3 letters. These are the same 3 letters you'll see when you look in your calculator for these things. All right, last one is what we call the cotangent, and that's the reciprocal of tangent. It is the adjacent over the opposite. So we're going to do, I'm going to do 4 examples with you, and then Mr. Rondeau is going to do some examples with you. The 4 examples that I'm going to do is just literally just recognizing these ratios, and we did make up an assignment to go with this, and it's going to be very similar to just having to recognize the ratios to delta math. I don't know if they're going to simplify or not. You'll just kind of have to figure that out as you go in there. Okay. All right, here we go. So all I'm going to do is I'm going to start with the first 3 trig ratios. That's just usually where I start. Find my sine, find my cosine, find my tangent. So in this particular triangle, here's my reference angle. It might not always be in that corner, so I have to go with wherever it's at. My sine, I know is, and I actually, before I even do that, sometimes I label. I might put a little O here for opposite. I know that that one's the hypotenuse and the leftover one is the adjacent. And that at least helps me know, okay, I know which one is which. And then I know sine is opposite over hypotenuse. So opposite is 3 and hypotenuse is 5. So I'm going to write that in there. And the only reason that we have this fancy animated one is because I made it during my master's degree when you guys were just barely born. So I don't know. What year was Danae born? Okay, yeah, I did this in 2005. So you guys were like 1 or 2, maybe 3, maybe not even. All right, pretty soon it's going to be older than the students. Isn't that nice? All right, okay. The cosine is going to be the adjacent over the hypotenuse. So the adjacent over the hypotenuse is 4 over 5. And our tangent is going to be our opposite over our adjacent. So in this case, it would be 3 over 4. Now, all I'm going to really do, sometimes you're going to have to find all 6. And a lot of times you have to find all 6. And so if you find all 6, all I have to do for the other 3 is just flip the reciprocals. So we could just simply flip the reciprocals. I know that sine was 3 over 5, so cosecant has to be 5 over 3. And we do want you to understand that relationship that they are reciprocals. Secant is going to be, if the cosine was 4 over 5, secant's got to be 5 over 4. And then tangent, I'm going to do a little differently in example 2. Tangent was 3 over 4, so cotangent would be 4 over 3. So all I did was flip reciprocals from what we did on the first 3 to what we did on the second 3. When I do example 2, I'm going to do it a little bit differently so that way you see it a slightly different way. Okay, example 2. And again, we have some nice numbers on these triangles. They aren't necessarily always going to be that nice. They could be, these are nice Pythagorean triples. They fit the Pythagorean theorem, but they might not always be that way. You'll notice my reference angle changed location. So I'm going to relabel my triangle. So I know that 12 is on the opposite. I know that across from the right is my hypotenuse, so that's the 13. And 5 would have to be, is the leftover, that's my adjacent. I'm sorry, I got a little extra squiggle there. So my sine, I know, is opposite over hypotenuse. So when I do opposite, I would do 12 over 13. Cosine is adjacent over hypotenuse, so I would do 5 over 13. And then tangent is opposite over adjacent, which would be 12 over 5. I'll pause there for a couple seconds and then I'll move to the next screen. All right, so this time I'm going to pretend that I didn't just do sine, cosine, and tangent. And we're going to actually look at practice the ratios from here. So again, I know this is opposite, hypotenuse, and adjacent. So slightly different technique, same idea, okay? So I know that cosecant has to be the hypotenuse over the opposite. So I would write my 13 over my 12. I know that secant has to be the hypotenuse over the adjacent. So I would write 13 over 5. And then cotangent has to be the adjacent over the opposite, which is 5 over 12. All right, let's see how we're doing. We're doing really good on time. Okay, so I'm going to keep going. I'm going to see what example 3 and 4 look like here because I don't remember. That one, actually, I'm going to skip example 3. That one it doesn't reduce nice. So, all right, let's look at example. Oh no, example 4 doesn't reduce either. We'll do example 4. We're going to pretend that we're not going to reduce the fraction. So, but I think hopefully you guys have kind of got the idea, and hopefully this is review. So hopefully you've seen this before, for the most part. All right, so there's my angle right there, my angle theta. I know across from my right angle, which almost doesn't look like a right angle. That's a bad picture. Is the hypotenuse. Doesn't look like a box. And then my opposite is across from the 12, and my adjacent would be next to the theta. All right, so as we've talked about, sine is the opposite over the hypotenuse, which in this case is going to be 12 over 15. And I'm sorry about all those extra little marks. That's my machine. All right, and then the cosine is the adjacent over the hypotenuse, which would be 9 over 15. And then the tangent is the opposite over the adjacent, which is 12 over 9. So I'm going to give a little bit of an extra pause this time. And why don't you guys take a couple of seconds and see if you can either get the reciprocals flipped for the other three, or write them down what they are from the triangle. So I'm going to give you probably like 30 seconds to do that. Okay, let's check it out. So I'm going to assume we flip the reciprocals. So the sine was 12 over 15. So this one's going to be 15 over 12 for cosecant. The cosine was 9 over 15. So the secant's got to be 15 over 9. And the tangent was 12 over 9. So this one's got to be 9 over 12. Yes, we could reduce all those fractions. We're just choosing not to in this. I don't know if Delta Math's going to make you do it because I didn't look that closely. So just be careful. Watch that. If you're getting it wrong, try reducing the fraction. All right. I think this is where you're going to take over, Miss Rondeau. Okay. So I'm going to go back in. I'm going to stop presenting my screen. That's okay. We're patient. I need to get Andy in here. I'm going to find Andy and we'll find a joke too. So you go ahead and start when you're ready. Andy, come tell a joke. If you give me like 3 seconds, Miss Rondeau, I'll have a joke. Here he comes. I hear him. He's bouncing up the stairs. Here he is. Okay.
Hello.
Come over here. Oh, don't show them the pile of laundry. That's bad. Okay. All right. There you go. Andy, tell us the joke.
What do you get when you cross a science fiction film with Toad? A toad.
What do you get when you cross a science fiction film with a toad? I don't know. What do you get?
Star Wars.
Starwarts. All right. Thank you for the joke. Appreciate it. See you later. Hope your homework's coming good. Yes, we can see your screen. Can everybody else see your screen? Okay. I'm getting like the one and Ashley, I can see her nodding her head yes. So we're good. Oh, what about 8? Oh, there it comes. 8, 15, 17. Can you talk about the, Miss Rondeau, can you talk about the multiplying them by 2 or 3? And you guys, it doesn't go away, you guys. I was doing an AP Calculus free response problem on Saturday with the AP kids, and we had a 345 show up, but we had to multiply by 100. So it comes up all the time. Yep. No, we do not. They either are all getting it or we're just seeing their little faces, their little icons, one of the two. I know that Ashley and Brody are there because I can see them. We are. It's probably because they're not interrupting us very much. So why doesn't everybody type that into the chat? I'm watching. See if you can really quickly find the third side. Oh, we're getting a lot of good things. Genesis was the first one. She said 8. And then we've got Ashley and Fallon and Dima and Casey and Sach and Brandon and Valerie and Jesus and Brody and Cynthia and Stephanie. We've got them all. They all say 8. So they've been listening and they're still there. Okay, if you think you know it, put it in the chat. I'm watching. Not so much, Miss Rondo. We don't remember. Yes, we are. That's why geometry is so awesome. You don't have to use negative numbers. Yes. Yes, we will be rationalizing our denominators. If there's any questions, put them in the chat or you can come off your microphone. We're not seeing any questions, Miss Rondo. Mrs. Rondeau, why didn't you use 4 squared plus 7 squared? I always say that you multiply a radical times itself, you get the number underneath. We're at about quarter till. We're at about quarter till 11. Which ones did you say which ones did you say you skipped? Was it 10 and 11 or 11 and 12? It doesn't really matter which ones we do. What do you want to do? Okay, sounds good. And so do I, Miss Rondo. I always draw that triangle. Yeah, always draw the triangle. Mine goes the other way, but I always draw it. Mine draw. I use I draw the opposite right triangle that you, but I always draw it. Yep. Oh, good. It's a Mrs. Ballard triangle now. Or your hypotenuse. Yes. We're getting a lot of tens. Awesome. That looks so great. I'm super excited because today I get to tell the story. So I'm going to go ahead and start sharing my screen. So I'm hitting share now. Let's see. Okay, so everybody should hopefully be seeing my screen now. And hopefully so again, this PowerPoint that I'm going to show you is almost, you were probably like 1 year old when I made it. So I'm going to hit hide. Okay, here we go. So we have a super awesome way for you guys to remember this. So this is the story of Sohcahtoa. Once upon a time, there was a little Indian boy. He was about to the age when all the little Indian boys get their Indian names, like runs like deer, swims like fish, and howls like wolf. This particular Indian boy loved math. He was always reading his math book. Today he's reading about negative and positive numbers. The Indian boy was kind of an outsider. All the other Indian boys made fun of him. One night they were having an initiation bonfire, and all the little Indian boys were dancing around the fire. There they go. Including the math-loving Indian boy who was still reading his math book. He wasn't really paying attention to what he was doing. And his toe caught on fire. It's a little slow. Here it goes. Keep going. There it goes. Luckily, there was a stream nearby. So he ran down to the stream and put his toe in. The other little Indian boys were still laughing at him. And one of them said, "Now we can call him Sohcahtoa." The little Indian boy's eyes light up. He loved his new name because it was so mathematical. Since sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So that's where we get Sohcahtoa from. But it doesn't end. Later that year, Sohcahtoa discovered girls. He chose his new girlfriend by her name, Sohcahtoa, which was also mathematical, since cosecant equals hypotenuse over opposite, secant equals hypotenuse over adjacent, and cotangent equals adjacent over opposite. So you've probably seen the sign. I don't know if it's on the next slide or not. Oh, nope. Let me go back to this guy here. You've probably seen this sign hanging in our classrooms, and now you know what it means. It's Sohcahtoa and his girlfriend. So, and hopefully you notice that, I don't know if my pen's gonna work. Gotta pull it out. Hang on, there it goes. Okay, so notice it's opposite, hypotenuse, and again, hypotenuse, opposite. These guys and the reciprocals are stacked on top of each other when you look at the sign. So you should be able to catch the reciprocals really easily based on the sign. Right? Yeah. All right. Do you have any questions at all? I'm going to stop sharing my screen. Anybody have any questions about today's lesson? The upside of us teaching when there's no class is we're allowed to, it was fun, Mrs. Rondo. I can't wait to do it again. How about in like 23 hours we do this again? All right. The nice part is when we're done, we get to let them out early because there's no passing period, no bells or anything. So What the other part is so I put it up in my Power School. I know Miss Rondo will probably put it in her Google Classroom. There is an assignment out there for you guys to try. So if you go look at Power School, I added a new page and it should be obvious. It's a Delta Math assignment. And then I also put an assignment in there you can turn in and hand in through Power School. And I'm sure Miss Rondo will put one in her Google Classroom or wherever it is. Oh, we need the Greek alphabet here in a second. Okay. Fallon just asked. And then, so if you guys, what we want you to do is take pictures of your notes, and that's kind of your proof that you were here and you did it. And we will throw some other enrichment points in the grade book for that. Does that sound good, Mrs. Rondo? I know we didn't talk about that ahead of time. Yes. Okay. Yes. Yes. I don't think so. I think just do the problems. And I'm going to say 70% and above will get you the full whatever points. We decide full 50 points for homework, and then we'll do a percentage up to that point. Okay? All right. We need to hear that Greek alphabet. Yes. As far as I put mine as Monday technically, but technically I think our final due date for the semester is going to be the 29th is where we probably are going to want things in by. Good job, Mrs. Rondo. Oh, you're getting some applause. You got some smiles too. So for the ones that have their cameras on. So we really appreciate that. All right. We will see you guys all tomorrow. Okay. Um, at, at 11 or at 10 o'clock tomorrow. Every day, 10 o'clock. All right. Bye.